Hey guys, welcome to eMath. Today we'll do 100 logarithmic equations and see how much time I need. Okay, before we begin, let me briefly go through the definitions and some of the laws of logarithms that we will need later, alright? So first of all, we need to know that logarithmic form is the inverse of exponential form, which we written like this: a raised to some power equals to some number. Alright, so when we write in logarithmic form, the whole log here is the power. Alright, is the power, is x. Okay, and then the base remain as the base, and then y will be the argument of the logarithm. Okay, but we have to remember that the base of the argument cannot be 1, cannot be 0, and cannot be negative, whereas the argument of the logarithm cannot be 0 and cannot be negative. Then next we have to know some short form. For log base 10 is lg, log base e is ln, which is the natural logarithm ln. Alright, and then we have to know some special values, which when the argument and the base are the same, log base a of a is equals to 1 and log base a of 1 is equals to 0. This is because when we convert this back to exponential form or index form, this is a equals to a raised to the first power, whereas this one is 1 equals to a raised to the 0th power. And we know that any number, any real number raised to 0th power is equals to 1 by definition. Alright? Then next we have some laws of logarithm. If the argument of the logarithm is some products, then we can split them into two logarithms and add them together. If it is a quotient, then we can also split them into two logarithms and put a minus in between. If the argument of the logarithm is in exponential form, we can bring this power in front and says that it is n times log base of a of n. Okay, then sometimes we need to change the base of logarithm. We can use this formula. Whatever on top will be always on top, whatever at the bottom, which is the base, will always be at the bottom. And then some common base that we'll use is lg, which is log base 10, and ln, which is log base e, the natural logarithm. Okay, we'll start with some easy one, which we can directly convert back using the definitions. Alright, so if we convert this back to exponential form or index form, we'll notice that 2 to the third power is equals to x, so x will be equals to 2 cubed, which is x. And then remember, ln is natural logarithm, which stands for log base e, so this will be e raised to the first power, so x will be equals to e. And then this is lg, which is log base 10. When we convert back, we have x equals to 10 to the negative 4th power. And remember, if it is negative indices, it is actually 1 over 10 to the 4th power. Alright, it is 1 over 10 to the 4th power, which is 0.001, almost 0. Okay, and then this one, 4 times ln x equals to 28. We can first divide both sides by 4 because we know that 28 is divisible by 4. And then with that, we can cancel out this and that, which is ln x equals to 7. Alright, so x will be equals to e to the 7th power. For this one, we can also directly convert it, and then we have 2x minus 5 is equals to 3 to the 2nd power, which is 9. 9 plus 5 is 16. 16 divided by 2 is 8, so x equals to 8. Okay, then we'll continue here. Okay, number 6, we have log base 2 of 7x plus 2 equals to 4. Same procedure like number 5, convert it back to index form. So we have 2 to the 4th power here, and then 7x plus 2 as the argument. So 2 to the 4th power is 16. 16 minus 2 is 14. 14 divided by 7 is 2. Okay. Then number 7, we have log base 6 of 2x plus 4 equals to 2. Okay. Convert back, 6 to the 2nd power equals to 2x plus 4. 6 to the 2nd power is 36. 36 minus 4 is 32. 32 divided by 2 is 16. Okay? Then number 8. Okay, this one is a little bit more complicated. We have log base 5 of 3x plus 5x plus 1 equals to 1. Okay? So same thing, we convert it back first, 5 to the first power. And for this, we can expand it using the FOIL operation. Okay, so 3x times x is 3x squared. And then 5 times 1 is 5. And then 3x times 1 is 3x. 5 times x is 5x. So 3 plus 5 is at x, okay, plus 1. And then this 5 to the first power, which is just 5. When we subtract 5 from both sides, we can actually cancel out like this. And we can factor out the x. So we have 3x plus 8 equals to 0. And then we have x equals to 0 or x equals to negative 8 over 3. Okay, number 9. Okay, don't worry, our question here so far is still very easy, but eventually we'll need more of the laws from just now, and eventually we'll get harder and harder question. But don't worry, we have 100 of them, and yeah, the question at the back will definitely be more challenging. Okay, number 9, we have log base at x plus 7, x minus 5 equals to 2. Always, first step, if we have a log on one side, a constant on the other side, convert back to index form. So it will be add to the second power, and then this one just expand it. X times x is x squared. 7 times negative 5 is negative 35. Then we have 7x minus 5x, which is 2x. Okay. Then x squared is 64. Okay. So 64. This will be x squared plus 2x, and then this should be minus 99 equals to 0. So I'm expecting a 9 and 11. Am I right? Then this should be x plus 11, x minus 9. So x equals to 9 or x equals to negative 11. However, check. This will be negative 11, negative times negative, this one should be okay, this one is negative 11 plus 7, which is negative 4. Negative 4 times negative 16 is positive, so both answers are acceptable. Okay, number 10. Okay, log base 2 of 2x plus 8x plus 4 equals to 5. Same thing, convert back to exponential form, expand 2x cubed, x times 8 times 4 is 32, and then we have at x, okay, at x plus 4 times 2 is also at x. Okay, and then 2 to the 5th power is 32. So 32 and 32 can cancel each other. Then this is 2x squared plus 16x equals to 0. Divide both sides by 2. Okay, so it is x squared plus 8x equals to 0. Factor x plus 8 equals to 0. So x equals to 0 or x equals to negative x. However, check. Negative times negative. Okay, so both are acceptable. Okay, number 11. Okay, so for number 11 to 15, I think we have to use the two special logarithmic values, which is when the base, okay, the base and the argument, if they are the same, we can say that it's equals to 1, and then log base a of 1 is equals to 0, because any number raised to 0th power is 1, as long as this is real. Alright? And number 11, we have log base 5 of y equals to 1. Equals to x, obviously. X will be equals to 1. Number 12, we have 2x minus 1 equals to log base 6 of 6 to the x power. Okay, so if this whole thing here is 1, okay, this whole thing here is 1 because of this property, right? So it will be 2x minus 1 equals to 1 to the x. And just now we said that 1 raised to any power is still 1. So 2x minus 1 equals to 1. So 2x equals to 2, x equals to 1. Okay? Then number 13. Of course, if I made any mistake throughout the video, please comment down below and let me know where I got wrong. Alright? Number 13, 3x equals to 7 to the log 7 of 6. Okay. Oh, by the way, we have one more thing that we need to know, which is if we have any number, log a raised to log base a of x, if we let it be y, okay, see what happens when we convert back to logarithmic, if we convert this to logarithmic form. Okay, let's say first I take log base a on both sides. Okay, a, then log a x equals to, okay, perhaps I should use red color for this. Okay, log base a equals to log base a of y. Just like we said that by power rule we can bring this one in front, isn't it? So log base a of x times log base a of a is log base a of y. And remember, when the argument and the base are the same, this is equals to 1. So log base a of x equals to log base a of y. By comparison, x equals to y. So what can we conclude from here? Is that whenever we have a to the log base a of x, which is like this, is equals to y, and y is equals to x is equals to x. Again, base raised to a log, a number raised to a log, and the base and the number are the same. It will just turns out be the argument. Okay? So if we make use of these properties, make use of this fact, we can do this very easily. Because you see that the base of this logarithm is 7, and then this number is also 7. So we can just happily say that this is 3x equals to 6, correct? Then divide both sides by 3, we have x equals to 2. Number 14, we have LG of 3x minus 2 equals to 1. LG is log base 10. Okay, so log base 10 of 1, we have 3x minus 2. Okay, so 3x will be, you add 2 to both sides, we have 12 on this side, then x will be equals to 4. Okay, number 15, we have ln half x plus 2 equals to 0. Convert back to index form, e to the 0th power, which is 1. Then we have half x plus 2. Okay, I told you that this is 1. 1 minus 2 is negative. Okay, 1 minus 2 is negative 1. Negative 1 times 2 is negative 2. So x equals to negative 2. And then check. Negative 2. This will be negative 1 plus 2, which is still positive 1. Correct? Correct. And then can the argument be 1? Yes. But the base cannot be 1. Okay, number 16. Okay, we are finally... Okay, no, not yet. We haven't get into the quotient rule and product rule. Okay. So before that, let me show you a move that is legal when we are solving logarithmic equations. Okay, number 16, we have log base 3 of 3x equals to log base 3 of 12. Okay. If you have a look at these two logarithms, they have the same base, and they are equals to each other, which means that they should have the same argument. So we can use a comparison method. If we have two logarithms side by side, and they are equals to each other, the base are the same, we can compare the argument, which we say is that, okay, by comparison, 3x equals to 12, so we can easily solve this one is equals to 4. Okay, number 17, we have log base 2 of 2x plus 5 equals to log base 2 of 11. Two logarithms side by side, same base, compare argument. Okay, so by comparison, okay, 2x plus 5 is 11. 11 minus 5 should be 6. Okay, so 2x is 6, x will be equals to 3. Okay, check, positive, no problem. Okay, number 18. Okay, number 18. We have log base 2 of 2x minus 3 minus, okay, minus log base 2 of x plus 9 equals to 0. We have two logarithms side by side, same base, same base, but then on the same side. But we can easily move this to the other side, which we say that log base 2 of 2x minus 3 is equal to log base 2 of x plus 9. Then with this, we can easily do our comparison, okay, by comparison. Okay, so 2x minus 3, okay, so 2x minus 3 will be x plus 9. Move things around, 2x minus x will be equal to x, then plus 3 on both sides. It will be 9 plus 3, which is 12. Okay, number 19. Ln 2x plus 1 squared equals to ln x 4x plus 5. Okay, we already have two logarithms side by side, same base. Directly compare the argument, okay, by comparison, and we should directly expand this. Okay, directly expand this. We have 4x squared plus 2 plus 4x plus 4x plus 1 raised to the second power is still 1. And then we can expand this one and this one. Remember to distribute the x to both terms inside the parentheses. So it will be 4x squared plus 5x. Okay, 5x. And happily we can cancel out this and that. And 5x minus 4x is x, so x equals to 1. Okay? Number 20. Log base x minus 1 e is 1. Remember what we said earlier? If the what's that? Okay, actually this one we can convert it back to exponential form and solve. But what I want you to know here is that when the logarithm itself is 1, then the base and the argument should be the same because of these properties. Log base a of a equals to 1. Remember, so we can directly say that e equals to e x minus 1. So x will be e plus 1, and that's it. Okay, number 21 onwards, we can use the product rule and quotient rule, which is, remember, when we have a log base a of n is log base a of n plus log base a of n. Okay, just remember, when we have two brothers sticking together inside this logarithmic house, their relationship is very good. So you add them, they have positive relationship. But if you have a quotient, you see, they are stepping on each other, means their relationship is not good. Relationship is not good means their relationship is negative. Okay, of course, if you want to know the legit proof of this one, I have made another video comparing the number of moves in Weiqi and also the numbers of atoms in the universe. Okay, I will put the link in the description down below. If you're interested, you can go and watch it. Okay, so anyway, we'll continue with number 21. And okay, the time now is, okay, we have used 16 minutes. Okay, I think I can do it maybe in 2 hours max. Alright, 2 hours max. Okay, number 21. We have log base 4 of x plus log base 4 of 3 equals to 2. See? Same base plus we use the product rule. Okay? So log base 4 of x times 3 should be equals to 2. So we convert this back to index form. We have 3x equals to 4 raised to the second power. 4 raised to the second power is 16. 16 divided by 3 is 16 over 3. Okay, number 22. We have ln 2 plus ln x equals to 1. Same base plus product rule. Okay, ln 2x equals to 1. And convert this back to index form. 2x equals to e to the 1. So x will be e over 2. Okay. Then number 23. Oops. number 23. LGX plus LGX plus 4 is LG12. Okay, obviously, we need to combine these two into one logarithm, and then we compare both sides, correct? So let's do it. Okay, log two brothers very good with each other. X times x plus 4 equals to log base 12. And then we say that by comparison, before that we distribute this x into the brackets. So we have x squared plus 4x equals to 12. Correct? We compare the argument. So x squared plus 4x minus 12 is 0. So x, I'm expecting 6 and 2, and then it should be negative 2 and positive 6 equals to 0. Yeah, because 6 minus 2 is 4. Okay, so x equals to negative 6, x equals to 2. Check. Can we have negative argument? No. So we need to reject this answer. Okay? So be very careful when you are doing logarithmic equation, because sometimes you really need to check so that you will not get inadmissible logarithm. Okay, number 20. And of course, if throughout the video I'm sure that I may miss up some of these steps, please remind me in the comment section down below. Alright? Then number 24. We're doing pretty good. It's only 20 minutes. Okay, number 24, but we have harder question later on towards the end. X squared plus log 5x equals to 4. What to do? Combine these two fellas. Okay, they are very good brothers. So x squared times 5x. Oh, we have an x cubed later. Okay, never mind. So we convert this back to index form. We have 5x cubed equals to 5 to the 4th power. But you know what? We can divide both sides by 5, isn't it? So 5 and 5 can cancel. X cubed equals to, this should be 5 raised to the 4 minus 1, which is 3. So we can directly say that x equals to 5. Okay? The thing is, we are, okay, this is actually about exponential. We are actually raising both sides to 1/3 power to make the index of x 1. And then coincidentally, this 3 and 1/3 can be cancelled each other, which is 1. So x equals to 5. This is the story. Okay? Anyway, we'll proceed with number 25. Log base 3 of x plus log base 3 of x plus 8 is equals to 2. Okay? Obviously, combine the two logarithms into a single logarithm. So we have log base 3 of x times x plus 8 equals to 2. Then convert this back to index form. X squared plus 8x equals to 3 to the 2nd power, which is 9. And then we have a quadratic equation. Minus 9 equals to 0. And okay, x, I'm expecting a 9 and 1. And then this should be positive 9 minus 1 equals to 0. So okay, right here, x equals to negative 9 or x equals to 1. However, check. We cannot have negative argument. So we need to reject x equals to negative 9. So x will just be equals to 1. Can the argument be 1? Yes. Okay, number 26. Okay, we are pretty good. You see, we only spent 21 minutes and we are done with 1/4 of our 100 log equations. Okay, let's proceed. We can proceed with this method. Okay, log base 8 of x plus 3. Of course, if you are interested to do this challenge, I'll put all these questions in the description down below. You can feel free to download it and try it on your own. Okay? And number 20 is okay. We log base 8 of x plus 5. Okay, I need more space. Sorry, number 24. Okay. Equals to, okay, where was it? Log base 8 of 15. Same thing, combine these two logarithms, compare it with the other side. Okay, so they are very good brother. X plus 3 times x plus 5 is log best x of 15. By comparison, after we expand this will be x squared plus 15. Then plus 5 plus 3 is x equals to 15. We are comparing the argument, yeah? And then, what else? This and that can cancel. So x plus x is 0. So x equals to 0 or x equals to negative x. Check. No, reject this answer. And another thing that I want you to mention, I want to mention is that when we are comparing the argument, actually, you know what? If we want to convert it back to exponent form, see what we get. See, x squared plus x plus 15 equals to add rest to the log at 15. You see, we can actually make use of the one of the properties of logarithm from just now. When the base of this log is the same as this number, the whole thing here will just be 15. See, isn't it what we have here? Okay, so this is a funny thing, this is interesting thing about logarithm is that no matter what rule you use, it is always very, very consistent as long as you don't go to the complex world. Okay, number 27. LGX plus LG x minus 9 is 1. Combine the two, so we have LG x times x minus 9 equals to 1. Then convert back to logarithm, and I don't think you even have to convert it, because you know that this fellow here should be equals to the best, which is 1. Okay, so x squared, again you see it is actually the same. It is actually the same. You convert back to logarithmic exponential form is 10 to the 1 power. You use the fact that if the argument and the base are the same, you'll get the 1, you will still get the same thing. Okay, so this is an interesting fact about logarithm, and in fact it is true for many formulas in math. It is always consistent. Oh, not always, it's like typically 90% of the time it should be consistent. Okay, so minus 10 equals to 0. We have a quadratic equation. X, okay. This one should be 27 is fine. Okay, we should have, I'm expecting 10 and 1. So plus 10 minus 1. Sorry, should be negative here. Negative 10 and plus 1. Because negative 10 plus 1 is negative 9. Okay, so we have x equals to 10 or x equals to negative 1. Check. So we need to reject this answer. Okay? Number 28. Okay, we are 25 minutes. Okay. Number 28. Okay, log base 2 of x minus 2 equals to 1 minus log base 2 of x minus 3. What should we do? Move this to the other side so that we can combine using the product rule. Okay, so log base 2 of x minus 2 plus log base 2 of x minus 3 equals to 1. Check if we can combine. Same base plus use product rule. So log base 2 of x minus 2 times x minus 3 is 1. Convert it back to index form. 2 to the first power, which is 2. Expand this one, we have x squared plus 6, then minus 5x. Okay, and then am I correct? Yeah, correct. So x squared minus 5x plus 4 is 0. Then x equals to 0. I'm expecting a 4 and 1 to make up my 5. And both of them should be negative. Okay, and negative, we are positive. Correct. Okay, so x equals to 4, x equals to 1. Check. 4 minus 2, okay. 4 minus 3, okay. 1 minus 2, not okay. 1 minus 3, not okay. Reject this answer. Okay, reject. Okay, number 29. 29 log base x plus 2. Okay, I think I need more space for 29. The question is quite long. Yeah, sorry about the cut because I copied the question wrongly just now. Anyway, when we have this long question, just combine these two, and compare the argument. Okay, so we have log base add of x plus 2 times 4 equals to log base add of x times 3. Then we can compare the argument. 4x plus 8 equals to 3x. So x will be equals to negative 8, which cannot be the answer because if you substitute back here, you will get a negative. Substitute back here also will be negative. So you have to reject this answer. Then how? You have no real solution for this question. Okay? And number 30. I purposely make this put this question because I just want to show you that sometimes we may not have real solution. Okay? But we can have complex solution and it involves I method. Okay? Well, we are not going to touch it today because today we are still living in the real world. Okay, number 30, we have log 3x plus 5 minus log. By the way, this stands for LG, which is log base 10, and we have 2x plus 4 equals to 0. Oh, this is very easy. Negative. Relationship not good. Relationship not good. How? Step on each other. 3x plus 5 over 2x plus 4 equals to 0. Convert back to index form. We have 10 to the 0th power. Then we have 3x plus 5 over 2x plus 4. 10 raised to the 0th power is 1. Then we can move this to the other side. Move things around. We have x equals to 4 minus 5, which is negative 1. Can we have that in our answer? Check. Negative 3 plus 5 is 2. Okay. Negative 2 plus 4 is positive 2. Okay. Number 31. Okay, 31 we have ln x minus 4 equals to ln 3. Double decker. Compare the argument. So 3x minus 12, then you should have 2x equals to 12, so x equals to 6. Okay? Number 32. 32. Log x plus 6 minus log 2 equals to log x. I feel like my handwriting is getting bigger and bigger. Anyway, negative quotient rule. Okay, so log x plus 6 over x plus 2 equals to log base x. Compare argument. 6 equals to x. X plus 6 equals to x squared plus 2x. So we have a quadratic equation. X squared plus 2x minus x is plus x minus 6 equals to 0. And then I'm expecting 2 and 3. Okay, and one should be positive, one should be negative. This should be positive, this should be negative, so that 3 minus 2 is 1. So x equals to 2, x equals to negative 3. Check. Cannot. Rejected. Okay. Number 33. Log base 2 of x minus log base 2 of 4 equals to 3. Double decker. X over 4 equals to 3. Then convert back to index form. So we have x over 4 equals to 2 raised to the 3rd power, which is 8. So x equals to 4 times 8. X equals to 32. Okay. And then number 34. lg x plus 8 minus lg x plus 1 equals to lg 6. Obviously, combine these two, compare the argument. Okay, so we have lg minus, so double decker. Okay, x plus x plus 1 equals to lg 6. By comparison, x plus x over x plus 1 equals to 6. So x plus x equals to 6x plus 6. So 5x should be x minus 6 is 2, so x equals to 2 over 5. Number 35. Log base 4 of 11x plus 3 minus log base 4 of x minus 7 equals to 2. I'm running out of space here. But anyway, obviously you need to combine these two and then convert back to index form. Okay? So log base 4, 11x plus 3 over x minus 7 equals to 2. Convert back, so it is 4 to the second power, x plus 3 over x minus 7. So 11x plus 3, 4 raised to the second power is 16. Then minus 16 times, 16x. 16 times 7, which is, I don't know, I will just use calculator, okay? 16 times 7 is 112. So 11x plus 3. So we have 16 minus 11 is 5x. 3 plus 112 is 115. Then 115 divided by 5 is 23. Okay. Number 36. No lah, I didn't cheat lah. It's okay to use calculator for big numbers. Okay. Anyway, we'll proceed with number 36. Okay. Oh, this time our x is the base minus, okay, but then this one is still okay, equals to 2. I don't care what base it is, as long as it is the same, we can combine them together using quotient rule if it is minus in between. Okay, so log base x of 18 divided by 2 is 2. Convert back to index form, we have 9 equals to x to the second power. And then we take square root on both sides, remember the plus minus. So x should be equals to 3 or x equals to negative 3. However, the base cannot be negative. Therefore, we have to reject this answer. Okay, number 37. What time is it? Okay, 40 minutes, about 40 minutes. Okay, log base 2 plus 14 minus log base 2 of 3. Double decker. Log base 2 x plus 14 over x equals to 3. So x plus 14. 2 raised to the third power is 8. 8 times x is 8x. Okay, so 7x equals to 14. X equals to 2. Okay, number 38. My skill is still not enough to write in 2 pens. Log base 2 of 3x minus log base 2x minus 3 is 2. Oh, it's 2 again. So log base 2, 3x divided by x minus 3 is 2. 2 raised to the second power is 4. Then times with x minus 3, 3x. So 3x equals to 4x minus 12. So x will be 12. 39. Ln 5 plus 4x minus ln 3 plus x equals to ln 3. Combine, compare argument. Okay, so ln 5 plus 4x, 3 plus x equals to ln 3. So 5 plus 4x equals to 3 times 3 is 9 plus 3x. So x should be 9 minus 5, which is 4. Okay. Okay, so far on average we are using 1 minute per question. About 1 minute per second. Okay, number 40. Okay, number 40. But I'm still on the first patch, okay. X plus 10 minus ln x plus 4 equals to ln x. Combine, compare. Okay, ln x plus 10, x plus 4 equals to ln x. Compare, so x plus 10 equals to x squared plus 4x. Quadratic, don't be afraid. X squared plus 3x minus 10. I'm expecting 5 and 2, and this should be positive, this should be negative. So x equals to negative 5, x equals to 2. Check. Reject. Okay, for this question, I want to show you another method. Okay, which is like this. You see the magic here. If it is 2, and then let's say I don't want to move this the other side, then how? I just make this also into a logarithm so that I can combine these two together, right? Okay, so you see what I do here? 2 times log base 3 of 3, which is 1, and plus log base 3 of x minus 1. See, I just want to show you another approach of doing this kind of question. Okay, and then you can use the power rule to bring this out on top. So it is log 3 squared plus log 3 x minus 1. Then log 3 x plus 7 is log base 3 product rule. Okay, 9 times x minus 1. Okay, which is 9x minus 9. Okay, so actually you can still do the compare the argument. So x minus 7 equals to 9x minus 9. So at x will be equals to 16, x will be equals to 2. Okay, so if you want to do it like how we did just now, you will be doing this. You will be moving this to the other side, which is a minus, and log base 3 of x plus 7 over x minus 1 is equals to 2, and then you convert back to index form, which is 9, and you see 7 equals to 9 x minus 9. You see, we still eventually end up the same equation. Okay, I mean this one, and this one. Okay, so this is an interesting thing about logarithm. This is the same thing. It is always consistent. No matter which rule you use, which law you use, you will always get the same answer. Okay, and the reason why I want to bring this up is because for the next question, I would prefer to do it this way. Okay, and of course, if you want to use the quotient rule, product rule, also up to you for the next question. Number 42. Okay, we have log base 2 of sub x minus 1. Log base 2 of x minus 2. Okay. Can you see why I don't want to use the quotient rule? Is because later on, if I move this to the other side, I will have sub x minus 1 over x, which looks scary, right? So let's say we try to use the approach just now. We don't touch this logarithm with sub, okay? Log base 2 of x minus 2 times log base 2 of 2, and then log base 2 of sub x minus 1 equals to log base x of x times. Use the power rule to bring this one on top, and then 2 square will be equals to 4. So log base 2 of sub x minus 1 equals to log base, sorry, this one should be 2. 2 of x over 4, correct? Minus 1, so this is double decker. And then by comparison, sub x minus 1 equals to x over 4. And I think we have no choice but to square both sides. But when you square root, remember you have to be very careful. Okay, so sub x equals to x minus 4 plus 1. I put this one here so that it's easier for me to rest to both sides. Okay, I rest both sides to second power, which I square both sides. So I have x equals to x squared over 16 plus 1 over 2x plus 1, and then I multiply both sides by 16 plus 16. So I have x squared minus x plus 16. So x, I'm expecting a 4 and a 4, and it should be negative, negative. Oh, so it is x minus 4 squared. Oh, it's a complete square. So x equals to 4. Okay, so obviously if you want to do it the other way also can, just that instead of comparing this and that, I mean, you will have set x minus 1 over x equals to, oh no, okay, then you will be raising 2 to the negative 2 power, because you convert it back to what's the exponential form, which is also the same, because this should be set x minus 1 equals to 1 over 4x. Isn't it the same as this one? So you see, it is always the same no matter which rule, which law you use, because it's logarithm. And number 43, just be very careful when you are squaring a square root, because you have to know that if you square this one, you will always get a positive version of x. Okay. Almost an hour. 43. Okay, ln 4x minus 2 minus ln 4 equals to negative ln x minus 2. Okay, we'll do this very quickly. Okay, okay, actually, you know what? I will bring everything to one side. Minus ln 4 plus ln x minus 2. And I don't do a comparison, I just directly like that. Okay, so ln minus, which means it is divide. Okay, minus means divide 4x minus 2 over 4, plus means multiply. Okay, equals to 0. E raised to 0 is 1. Then you just expand this one. 4x squared plus 4. Then this should be negative 2x, negative x. And then sort out. Minus 10x plus 4 equals to 4. This and that cancel. Divide both sides by 2. Okay, am I doing it too fast? This is 0 already. So 2x squared minus 5x equals to 0. So x, and I'm expecting x and 2x. And then, oh, you know what? Just factor out the x. Sorry. Just factor out the x. So we have 2x minus 5. So x equals to 0 or x equals to 5 over 2. Check. 0 minus 2 cannot. So 0 minus 2 cannot. So we reject this answer. And so okay? 5 over 2. 5 over 2, okay lah. Number 44. Number 44. And hash 2. Okay. Log base 2, 7t minus 2 minus log base 2, 2t, then plus 1. This one is separate, like this. Okay, equals to 0. Combine, move this to the other side, okay? So log base 2, 7t minus 2 over 2t equals to negative 1. So 7t minus 2 over 2t equals to 2 raised to negative 1 power, which is 1 over 2. 1 over 2 is 2. 1 over 2 times 2t is t, so 8. No, 6t equals to 2, so t equals to 1 over 3. Number 45. Okay, should be enough. 45. 3 minus log x3 equals to log x9. Don't panic when you see an x as the best, because you can move this to the other side. Okay? Plus, like this. And of course, if you want to use this one as 3 times log base x of x also can. And then you combine also can. So you have a lot of alternatives, a lot of methods, and it will result in the same answer. Because this is 3 equals to log base x, but I will do it this way because I can see that 9 divided by 3 is very easy. So log base x of 3 equals to 3. So 3 should be equals to x to the third power, so x should be cube root of 3. Okay. You see, I made a mistake. So I shouldn't be this one. Okay. This one plus, so should be 9 times 3, which is 27. X to the third power is 27, so x equals to 3. Okay. You see, because I was talking about minus, right? So I was thinking about what divide. But since I put it here, I shift it here, then it is plus, so it is times. Okay. 46. Let's see if we can do 50 questions in 1 hour. 46. If not, I think I will take more than 2 hours for this. X squared equals to 2 plus log base 3 x plus 4. Obviously, you can't compare this to 100 derivative, 100 integrals, 100 system of equations. Okay. Anyway, do this very quickly. Okay, choose whatever method you want. If you want to shift this to the other side, make sure that you use quotient rule. So log base 3 of x squared over x plus 4 equals to 2. So x squared over x plus 4 is 3 raised to the second power, which is 9. So x squared minus 9x minus 4 times 9 is 36 equals to 0. X equals to 0 should be a 12 and the 4. 12 and the 3. And then I want this to be negative, I want this to be positive. So x equals to 12, x equals to negative 3, and then check. You square the negative so it becomes positive. Okay. Negative 3 plus 4 is positive 1. Okay. Okay, number 47. X plus 20. Okay, I need more space. Because my hair is so big now. 47. Log base 2x plus 20 minus log base 2x plus 2 equals to log base 2 of x. So directly x plus 20 double decker x plus 2, compare the argument. So x plus 20 equals to x squared plus 2x. So x squared plus x minus 20 is 0. Obviously, I'm expecting a 4 and 5. And then I want this to be positive, this to be negative. So the x equals to 4, x equals to negative 5. Check. No, reject this answer. Okay, number 48. X plus. Combine. So x plus 1 over x equals to 8 raised to the second power, which means x plus 1 is 64x. Oh. Okay, 63x equals to 1, so x equals to 1 over 63. Pretty ugly, this answer. Okay, number 49. Okay, we have 2 more minutes. No, 1 minute plus, so we have 2 more questions. Okay, let me rush through this. 49 and 50. Oh shit, 49 is so long. Question is so long. Okay. 49. LG3 plus LG2H minus LG3H plus 1 equals to 0. You see, I'm very happy to see a 0 here because you know what? This one you can combine this, divide, equals to 10 raised to 0 power is 1. Okay, so 6H equals to 3H plus 1, which means 3H is 1, H equals to 1 over 3. Number 50. 30 seconds. 1 plus y plus log base 2 of 5 minus y, 3 plus log base 2 of y minus 2. Okay, move this to the other side. So I have log base 2, 1 plus y, 5 minus y over y minus 2 equals to 3. So 2 raised to the third power is 8. And then expand this one, 5 minus y squared, then plus 5y minus y, add times y minus 2. It cannot last our time already, but we still have to do all of them. Anyway, so this should be 5 plus 4y minus y squared equals to y minus 16. So y squared at minus 4 is 4y, 16 minus 5 is 11, equals to 0. Okay, and I think I made some mistake during I rush. Okay, anyway, let me redo number 50. I feel like something is wrong with it. Don't sleep after 1 hour. It's okay, it's okay. Number 50. Log base 2, we do it properly, okay? 1 plus y plus log base 2, 5 minus y equals to 3 plus log base 2, y minus 2. Move this to the other side, so we have log base 2, 1 plus y plus log base 2, 5 minus y minus log base 2, y minus 2 equals to 3. So log base 2, 1 plus y, 5 minus y over y minus 2 is equals to 3, so equals to 8, y minus 16. I feel like I'm making the same mistake again and again, is it? Plus 5 minus 4, plus 5 minus 1, plus 4y. I know where I get wrong. This is positive 16. No, negative 16, sorry, negative 16. I think this is where my mistake was. So y squared at minus 4 is 4y, negative 16 minus 5 is negative 21. Yeah, I can see already. I'm expecting a 7 and 3, and I want 7 minus 3. So x equals to negative 7, x equals to 3. But we have to reject, not x, y. Y. But we have to reject number. We have to reject x equals to negative 7. Check. Cannot. Okay? Oh. Okay. We don't have to reject this one. Just to reject x equals to negative 7. Okay. We're halfway. 1 hour and 2 minutes. Okay, number 51 onwards. Okay, let me revise one more rule for you, which is the power rule. Log base a of n to the n, you can bring it down. Log base a of n. Okay, you just remember this brother very naughty. It climbs up the roof and then it falls down. In front of forget. Okay, I don't know what I'm saying, but anyway, 51. Log base 3 of 3 to the x is 4. Bring this fella down. X log base 3 of 3 is 4. And then this one happily is 1, so x equals to 4. 52. Log base 2 of sub x. Obviously we can directly press calculator, but I want to do it by hand. So log base 2. What is 8? 8 is 2 raised to the third power. And then when you square it, it is half. Okay? So you can bring down this entire fella here in front. So it's 3 over 2 times log base 2 of 2, which is 3 over 2. Okay, 53. X equals to log base 6 of 1 over 2x6. Remember, when it is 1 over means negative exponent. Okay, so x equals to log base 6. How can we relate 6 with 216? 6 cubed is 216. So 6 to the negative 3 is 1 over 216. So it is 6 to the negative 3. So x obviously is the negative 3 times log base 6 of 6, which is 1, and x equals to negative 3. 54. Log base 4 over 5. Oh, this is very nice. Because 4/5, this is basically 4/5 squared, isn't it? So x equals to, bring down this further here, so it's 2 times 1. So x equals to 2. Number 55. X equals to the square root of log base 1/2, 1/16. Obviously, x equals to square root of log base 1/16. 2 to the 4th power is 16. So 1/2 to the 4th is 1/16. So 1/2 raised to the 4th is 1/16, right? So we have 1/2 raised to the 4th power. So x equals to square root of 4 times 1. So x equals to plus minus 2. Number 55, number 56. Ln x cubed equals to 3. Convert back to index form, or you can convert it back to index form. You can also bring this one down below. So 3 ln x equals to 3. Divide both sides by 3. So ln x equals to 0. Remember, if it is 0, then x equals to e to the 0, which is x equals to 1. Okay? And of course, if you convert this back, you have what's that? X cubed equals to e cubed. Wait, did I make any mistake? Oh, this is 1, this is 1. This is 1, this is 1, then this is e. Right? So e cubed, so x equals to e. Sorry for my mistake, okay? 3 divided by 3 is 1. You see, another column mistake, not 0, okay? Not 3 minus 3. Okay. Number 57. Log base 2, 4x equals to 5. First of all, 4 is 2 raised to the 2nd power. So we can bring these two together in front. 2x times log base 2 of 2, which is 1, So x equals to 5/2. And number 58. Log base 5, 1/25, x equals to 2. 1/25 is 5 to the negative 2 equals to 2. So negative 2x bring in front, log base 5/5 equals to 2. This is 1. So x equals to negative 1. Check. This will just give you a 25, so no problem. Okay, number 59. Ln x to the ln x equals to 4. Oh. Bring in front, ln x times ln x equals to 4. This one is ln x times ln x, okay? Not product inside the argument. It's a product of 2 logarithms. When we have product of 2 logarithms and they are same, you can happily say that it is ln x. The whole thing squared. Then you take square root on both sides, plus minus. So ln x equals to 2, or ln x equals to negative 2. So x equals to e squared, or x equals to e to the negative 2, which is 1/e squared. And check. No problem, they are all positive. Okay, number 60. Number 60, log base 2 of 7, 2 to the 7k minus 4 equals to 4. Obviously, you can bring this one in front, so it is 7k minus 4 times 1 equals to 4. So 7k equals to 8, k equals to 8/7. Okay. Oh, sorry, I copied the question wrongly. This is k squared. This is k squared. Sorry. This is k squared, but it doesn't matter. doesn't matter. It just means that we have a quadratic equation to solve. Alright, did I copy your question correctly? Yes, huh? Okay, so this should be k. I'm expecting a. Oh, okay. Okay, I think it's like this. Then this should be minus, this should be plus, I guess. No. 4k, 3k. Yeah. So k equals to negative. It should be negative. So that you see, k, 3k. Number 60. Log best at 7k minus 4 equals to k squared. Okay, so I think we need to do a change of base. But before that, let me move this one down. So 7k minus 4 times log base of 2 equals to k squared. So we change this to log base 2. Okay, so 7k minus 4 times log base 2, then over log base 2. Remember, whatever on top is always on top, and add is what? Add is the letter. Okay, so 7k minus 4. Log base 2 of 2 is 1 over log base 2 of add is 2 cubed equals to k squared. So this will be, you bring this one in front, so it is 1 over 3 times 7k minus 4 equals to k squared. So 3k squared minus 7k plus 4 is 0. So k, 3k, sorry. Should be a 1 and 4. Should be a minus. So k equals to 1, k equals to 4 over 3. Check. No problem. Okay. 61. Log base 5 of x minus 5 equals to 1 over 3 log base 5 of 1 to 5. Oh, very happy because I know that 1 to 5 is 5 cubed. Okay, so log base 5 of x minus 5, log base 5 of 5 cubed. And then you know what? I just bring this on top. So this 1 over 3, so that this and that can cancel. So I compare the coefficient. X minus 5 is 5, so x equals to 10. Number 62. 2 log 3 2x plus 1 log 3x plus. I'm running out of space here, so I will do it here. 62. Two times log base 3 of 2x plus 1 equals to log base 3 of x. Log base 3 of x plus log base 3 of 4x plus 5. Obviously, use a power rule, bring this on top, and then combine these two and then compare. Okay? So log base 3, 2x plus 1 squared equals to log base 3x times 4x plus 5. Then by comparison, expand this further. Plus 4x plus 1 equals to 4x squared plus 5x. This and that can cancel. 5 minus 4 is 1, so x equals to 1. 2 times log base 2x plus 1 minus log base 2x minus 1 equals to 3. Bring this one on top, so we have log base 2x plus 1 square minus means divide by x minus 1 equals to 3. Convert back to index form. X plus 1 square equals to x minus 8. Oh, I forgot to explain this one. This is x squared plus 2x plus 1. Okay, so we have x squared minus 6x plus 9 equals to 0. I'm expecting 3 and 3, both negative, so it is x minus, it's a complete square, x minus 3 squared equals to 0, x equals to 3, check. Okay, okay. 1 hour and 50 minutes. We have 45 minutes left. Okay, let me extend it, maybe 2 hours and 50 minutes, or 2 hours, 2.5 hours. 64. Right, 64. Log base 2 of x squared equals to 4 plus log base 2. Bring down, and you know what? I will move this to the other side. So, no, don't bring down, Minus log base 2 x minus 3 equals to 4. So log base 2 double decker equals to 4 x squared. Convert back to index form. 2 raised to the 4th power is 16. 16 times 3. I don't know what 16 times 3 is, so I will use calculator. It's 48. So x squared minus 16x plus 48 is 0. Yes, huh? Okay. X equals to 0. I want 16. So, oh, I know. Should be 12 times 4. Am I right? Then negative, yeah, correct. So x equals to 12, x equals to 4. Check. 4 minus 3, okay, no problem. Okay, 65. 2 log 3x minus log 3, 7x equals to 1. Oh, very happy to see a 1 here. So I will bring this one on top. Log base 3 of x squared minus log base 3 of 7x equals to 1. And then I will use the, what's that? Quotient rule. Convert back. 7x, x squared. So x squared equals to 21x. X minus 21, x equals to 0. So x minus 21, x equals to 0, x equals to 21. Check. Cannot, right? So we need to reject this answer. Okay. Number 64. Oh, okay. Number 66. Okay, number 66. Oh, sorry. Number 66. We have a division of logarithm. Just now we have a question like ln x times ln x, it is equal to ln x squared instead of ln x plus x, right? So now number 66, we have a division of logarithm, and 2 equals to 1. And very happily, the best of these two logarithms are the same, which means we can use the change of best formula, the inverse of it, I mean the reverse of it. Log base a of b equals to log base c of b over log base c of a, correct? Isn't it the same form as this one? So we can say that this is log base, whatever at the bottom, always at the bottom, whatever on top, always on top. So x equals to 2 to the 1, which is 2. Okay? Number 67. 5 equals to log base 2 of 3. Okay, you see, for this question, we cannot directly compare because the bases are not the same. Okay? Because the bases are not the same. But luckily, we can convert it to a convenient base, which is 2, to compare. So if we change it to log base 2, whatever on top always on top, whatever at the bottom always at the bottom. And you know what? Log base 2 of 4 is 2 square. You can bring the 2 in front by power rule. So it is 1 over 2 log base 2 x plus 5 equals to log base 2 of 3. And then you can bring this on top to compare. You can now compare it because you have the same base. So x plus 5 equals to 3. And then rest square both sides. Okay. Be careful when you square both sides now. X plus 5 equals to 9, so x equals to negative 4. Sorry, positive 4. Check. 4 plus 5, no problem. So x equals to 4 is the answer. Number 68. Oh. Okay, 4 log 2x equals to 5. What should we do? Let me erase this one because we may need more space later. We can take log on both sides. This is another legal move that we can do, which is we take log on both sides. And to make our life easier, I will take log base 2. And I already think of another method, which is you convert back to you convert to logarithmic form, which you have a log base 4 of 5 equals to log base 2 of x. And then you convert this one to log base 2 to compare. But anyway, I will take log base 2 on both sides and see what turns out. 5. So log base 2, this is 2 square times log base 2 of x equals to 5. I bring this one in front, so it is 2 log 2x equals, sorry, this one is log 2, 5. Okay, log 2, 5. Because I'm taking log base 2 on both sides, alright? So log base 2 of 5. Bring this one on top. By comparison. But the argument cannot be negative, so we only consider, we reject is square root of 5 or negative square root of 5. So we need to reject this one. Okay? If you can't think of taking log on both sides in direct extent, don't worry. Do this one, which you convert back to logarithmic form, and then you change the base. It's actually the same approach. 2, 5, whatever on top always on top, whatever at the bottom always at the bottom. You see, we're actually doing the same thing. Log 2, 5 over this is log base 2 of 2 square, which is a 2, and it is a half. Log 2, 5 equals to log 2x. Isn't it the same as this one? I write one more step for you. Half equals to log 2x, so x equals to 5 to the half, which is square root of 5. Okay? The number 69 is a very similar question to 68. Add to the log 4n equals to 27. You can convert it, you can convert it back to, but then this time it is, I think I will still choose log base 2, and I will change it to log base 2 for both sides. Okay, so log base 2 of 27, whatever on top always on top, whatever at the bottom. Add is 2 cubed. Okay, equals to log base. Oh, sorry, I also need to change to log base 2 for this one, so that is easier for me to compare later. 2 of 2 squared. Okay, so it is 1 over 3 log 227 equals to 1 over 2 log 2n. So 27 to the 1 over 3 is n to the 1 over 2. So n equals to, I raise both sides to second power, so that this can cancel. 27, 2 over 3, which is 9. Because after you take cube root is 3 squared is 9. Alternatively, I can tag log base 2 on both sides. Okay, let's say I don't tag log base 2 because I'm not sure whether I should tag log base 8 or log base 4 or whatever, right? Let's say I tag log. Okay, can I tag log on both sides? Let's see. Log 4n equals to log 27. Bring this one in front. Log 4n log 8. Yeah, equals to log 27. And then I divide both sides. Okay, let's say I use what's that? Black color for this one. I divide both sides by log 8. So that this and that cancel. Log 4n equals to, remember, this is a division of log, so you can use log base 8 of 27. Then isn't it what we have here, which we can do, or we still have to convert back to log base 2. We still have to convert back to log base 2. Log base 2 of 4, which is 2 square, and then we have the same thing here. 27 over log base 2 of 2 cubed, and then we can proceed with this one. 1 over 2, okay, 1 over 2 log 2n equals to 1 over 3 log 227. So n, square root of n is cube root of 27, so n equals to 3 squared, which is 9. Okay, so you see they're actually the same thing, just that you are using different laws. And by the way, as you can see from here, no matter what base you choose, even if you choose log base 10, you will still get the same result, because this fella here will always be the same. This fella here is equals to log 27 over log 8. It's equals to any base that you like. Okay, so because it is a ratio of 2 log. Okay, ratio of 2 logs means what? Means it is always the same no matter what base you choose. Okay, number 70. Sorry, I copied the question wrongly again. Anyway, we will change to log base e for all this, so that it will be easier for us to compare with the other side later. Okay, so log base, okay, I should use red color. Log base e of 2y over log base e of sub e is e to the half equals to log 6 minus 2y. And then this half we can bring it in front, and then if it is divide, means we are taking it like this. 2y equals to log 6 minus 2y. And what is log base e? Log base e is log, and then we can bring this one on top, so that it is 4y squared equals to log 6 minus 2y. Okay, when the bases are the same and side by side, we can compare the argument. So 4y squared equals to 6 minus 2y. So 4y squared plus 2y minus 6 is 0. Divide both sides by 2. Then we have 2y squared plus y minus 3 is 0. Y, then 2y. Should be 1 and 4, I think. 1 and 4. Let's use calculator. My brain is too tired for this. Okay. 2, 1, and negative 3. Yeah. Oh, sorry. And 2. Sorry. Then this should be, what's that? Minus for this one, plus for this one. So y equals to 1 or 3. What's that? Oh, sorry. Y plus 2y plus 3. 2y plus 3, correct lah. 3 times negative 1 is negative 3, and then we have, okay, we have 3 minus 2 is 1, okay? So y equals to 1 or y equals to negative 3 over 2, but we have to reject this fella here. We have to reject this fella here. Cannot be negative in the argument. So we reject this answer. Okay, it has been 1.5 hours and we have done with 70%. 30 more questions. Okay, it's like a marathon, you know. It's like a marathon that you need a good stamina for this. Okay, 71. So to reduce my suffer, I will do this very quickly. 1 over log base of x. So up to you, like if you want to change it to log base x also can. You want to change it to log base 2, it is also quite convenient for you. Okay. So let's say I choose log base 2 because I'm quite afraid of having a x as a base personally. Okay, anyway, I will change to log base 2. So log base 2 of 32 is 2 to the negative 5 because it is 1 over, right? Then log base 2 of x. Oh, you know what? I think we need to do a substitution later on to make our life easier, okay? So it will be 1 over the whole thing, log base 2 of the one on top always on top, the one at the bottom always on the bottom. That is 2 cubed. Okay? And then it is 4 minus 5, correct? You bring this one in front and this is 1. Okay, 5 over log base 2 of x equals to, flip it, then you bring this 3 in front, this is 1, so it's 3 over log base 2 of x. And I think I better do a substitution so that it is clearer and clearer and simpler for you to understand. Log base 2 of x. I let y be log base 2 of x. Okay, so I have 4 minus 5 over y. Of course, this is not necessary just to show you. Okay, and then I multiply both sides by y because you know what? I'm forming a quadratic equation. Okay, so 4y squared. 4y. No, quadratic equation, a linear equation. 5 equals to 3, so 4y equals to 8, y equals to 2. But remember, our question is x. Our question is x, so we need to go back to the x word. Okay, remember y was log base 2 of x equals to 2, so x equals to 2 to the 2, which is 4. Okay, so if you don't want to let y be log 2x also can, you just multiply both sides by log base 2 of x. It will do the same thing. It is basically the same as saying I multiply both sides by y. Just that in case you confuse yourself when you do this, because this looks scary, right? But anyway, we'll proceed with 72. Okay, this is a nice one. Log base 3 of y. Okay, I can see the trick already. 5 of 3 plus. Remember, it is a product of logs, and the products in the log are different. So how? Don't tell me that you can add 25y 3 together. No. You should be able to see it. A very smart trick. Let's say you have to convert to different base for all 3 of them, obviously. So let's say I change to log base 5 for this one. Okay, 25 is 5 squared. Then log base 5 of 2. That's it. Then what should I change this one to? Let's say I change it to log base 5 also. Let's say I change it to log base 5 because I think you can see where I'm going. I want to cancel out stuff, right? And then I don't touch this log base 5. Oh, sorry, log base 5 of 3 plus 4. See, I want to cancel out stuff. This and that can cancel, and then this is just 1. And then this should be 2 times log 5y over log 5(2), which you can change the base, isn't it? Equals to, okay, let's say I move this one to the other side, -4. And then I divide both sides by 2 first. Reverse of change of base formula. Log base 2 of y equals to -2. And then y should be 2 -2, which is 1 over 4. Happy? Okay, 72. And is there any other way of doing this? Obviously, if you don't know what base to change to a common base, log base 10 or log, and press calculator. You should be able to get the answer. Okay? Number 73. This is a very nice question, to be honest. 73 log 2x minus log sec 2x equals to. Change to log base 2 minus log base 2. Remember the whole thing, is the whole thing, okay? Log base 2 of sec 2 is 2 to the 1 over 2. Then after you convert, this should be 2 in front is the 2 log 2x equals to 1. You can use the quotient rule, combine these two fellows together. And before that, this one bring top, so log base 2 of x over 2 squared is 4, x squared equals to 1. Convert back to index form, 4 over x over 4x squared equals to 2 to the first power, which is 2. So x equals to x squared, at x squared minus x equals to 0. X at x minus 1 is 0. X equals to 0 or x equals to 1 over 8. Check. Okay, no problem. Number 74. And 74. X equals to log base 2 of 25 times. You see, be careful when it is times. And this is very, very troublesome. Be careful when it is times because you cannot add up stuff. But let's say we change it to the same base, and I think we can change it to log base 2. Let's try it. I'm not sure. Log base 2 times 25 times log base 2. Oh, okay. I think I can. I know how to do it. Log base 2 of sec 2. Sec 2 is 2 to the half over log base 2 of log base 2 of 5. Okay, and then 25 is 5 squared. See where I'm going? Bring this one in front, log to 5 times. Bring this one in front, half times 1 is just half, then log base 2 of 5. Do you notice that we can actually cut? Cancel this and that? Then 1 half times 2 is just 1, so x equals to 1. Very nice. Number 75. Okay. 3, 4 already. Okay. Oh, this one I need more space because the question is long. Okay, well, 1 hour 40 minutes. I think I can do it in 2 hours and 30 minutes max. I'm not sure because the question at the back are quite okay. Actually, still okay. Just now we were at 75. X equals to log A sub B. We are starting to have interesting questions, right? So we have all these funny questions. What does C of A for? Different base again. Multiply again. And we need to be smart to change to some convenient base so that we can cancel out stuff. So let's say I change to log base B for the first one, or should I change to log base C? Yeah, maybe I change to maybe I change everything to log base C. It will also be easy, right? Okay, let's see. Log base C of B half over log base C of A. Okay, equals to log base C of C cubed log base C of B. Then this one don't touch. Okay, and then use the power rule to bring everything down. 1 over 2 log base C of B log base C of A. 3 times log base C of C, which is 1 over log base C of B. 4 log CA. 3 times 4 is 12. 12 times half is 6. Another very interesting question. Okay, just be smart, right? I believe if you want to change it to Log base A also can. It also works because you can bring down this one. If you want to change it to log base B, also can, I believe. Just that I think if you try log base B, the step will be the longest. Log base A looks fine, and log base C looks fine. Okay. Number 76. For log 2x equals to, oh, okay. Okay, this one definitely if we do a substitution, it will be easier for us because I can see quadratic already. 4y equals to y squared, so y squared minus 4y is 0. y minus 4 is 0. So y equals to 0, or y minus 4 is, or y equals to 4. Okay, and then unsub, go back to the x world. X equals to 0. 2x equals to 4, so x equals to 2 to the 0 is 1, x 2 to the 4th is 16. Okay. This one is the same thing. Just practice your let number 77. Yeah. So we let y be logx, so that it will be y squared plus 2 equals to 3y. Y squared minus 3y plus 2 is 0. I'm expecting a 2 and 1, and then it should be both negative. So y equals to 2, y equals to 1, and sub lgx equals to 2, lgx equals to 1, x equals to 10, x equals to 2 squared is 100. Okay? 1 hour 45 minutes. $78 log base 3 of x plus log x 9 equals to 3. Okay, this obviously I will change it to, you can either change it to log base 3 or log base x, but log base x seems scary, so I just have log base 3. Of course, you can change it to any base you like. If you don't know what base to change to log base 10 or log base e. Okay, 9 is 3 squared over log base 3 of x. Okay, log base. And then I think we need to do a substitution later so that it's easier for us to see. Okay, so it will be log base 3 of x plus 2. This is 1 over log base 3 of x equals to 3. You can see it's a quadratic lah. You will get a quadratic. And if you can't see it, let y be log base 3 of x. So y plus 2 over y equals to 3. So multiply both sides by y. You have y squared plus 2 equals to 3y. So y squared minus 3y plus 2 is 0. I'm expecting a 2 and 1, both negative, which is 2 and 1, and then unsub x equals to 3 squared, which is 9, x equals to 3 to first power, which is 1. Check, both positive, no problem. $79. Same story. I can see the same pattern really. Okay, but change to log base 8 for this one. Log base 8 of 8, very nice. Log base 8 of x minus 2, so 3 log at x equals 1 of log at x equals 2. Do the substitution, or minus 2, sorry. Let's do the substitution. Let y. Of course, this is not necessary lah. Just for you to see that it is a quadratic. Okay, so 3y squared minus 1 minus 2y. So 3y squared plus 2 minus 1 equals 0. 3y. It should be Just one. My brain not functioning anymore. Never mind, just calculator. 3, 2, minus 1 and plus 1. Okay? So y equals to negative 1, y equals to 1 over 3. So log base at of x equals to 1 over 3. So x equals to 1 over at. X equals to at to the 1/3, which is 2. Okay. Number 80. Hey, we might be able to do it in 2 hours. No, just kidding. I don't think so. Log base 3x. The whole thing square, okay? Minus, okay, this the square only belongs to the x. Equals to 3, but obviously another quadratic. If you can't see it, let me show you. Bring this one down. 2 times log 3x equals to 3. Let y be log 3x. Y squared equals to 2. Is it? Sorry, some minus. Equals to 2 times y equals to 3. So y squared. I'm expecting a 3 and 1. And then this should be minus, this should be plus. So y equals to 3 or y equals to negative 1. So log base 3 of x equals to 3, log base 3 of x equals to negative 1, x equals to 1 over 3, x equals to 3 times 3 raised to the third power is 27. Okay? Number 81. Ln x squared is, oh, this is very similar to this one, right? Bring this one down. 2 ln x equals to ln x squared. Then let y be ln x, so 2y equals to y squared. Y squared minus 2y is 0. So y minus 2 is 0. Y equals to 0, or y minus 2 is 0. Or y equals to 2. Okay? Then ln x equals to 0, or ln x equals to 2. So x equals to e raised to the 0 power is 1. E raised to the second power is e squared. Nice. 82. Ln fourth root of x equals to square root of ln x. It's exactly the same pattern, I tell you. This is 1 over 4. This is okay, just don't touch this one. Just that later on we need to square both sides, obviously. Bring this one in front. 1 over 4 ln x equals to square root of ln x. Let y be ln x, so 1 over 4 y equals to the square root of y, and then square both sides. And then we have 1 over 16 y squared equals to y. So y squared minus 16y is 0. Y minus 16. Y equals to 0. Y equals to 16. Y is ln x. Y is ln x. So x equals to e raised to 0 is 1. X raised to e raised to 16 is 16. Okay. Three. Page 3, very nice. Okay, but it's the same thing, right? It's the same thing. Why do I have so many questions like this? Okay, so square root of ln x equals to ln x to the half. Bring this one in front. Then we let y be ln x. I shortcut a few steps already. Y equals to half y, and then I square both sides. Square both sides, so y equals to 1 over 4 y squared. So y squared minus 4 equals to 0. Oh, no need, just 4y. Sorry. Okay, so y minus 4 equals to 0. Y equals to 0. Y equals to 4 ln, ln x equals to 0. Ln x equals to 4. So x equals to e to the 4th. X equals to e to the 0 power, which is 1. Okay. We have so many similar questions. That's why I go through very quickly, because they are the same. They are basically the same. 64 ln x squared plus 16 equals to 10 ln x. Okay, this obviously will let y be ln x. Just do whatever substitution that make yourself feel better looking at the equation. Okay, so y squared plus 16 equals to 10. Y is the quadratic, obviously. Then obviously I'm expecting a 8 and 2, and then this should be minus. Okay, so y equals to 8, y equals to 2, so ln x equals to 8, ln x equals to 2, so x equals to e to the 8, x equals to e squared. Nice. 85. Log 2x equals to 4 log x2. This one obviously. Change this one to log base 2 so that it's easier for you to compare. 4 times log base 2 of 2 over log base 2 of x. Log base 2 of x equals to 4 over log base. No choice that you have to do substitution. And then make it a quadratic equation. So y will be 2 or y will be negative 2. And then this is log base 2 of x equals to 2. Log base 2 of x equals to negative 2. Remember, whenever you do substitution, make sure to convert it back to the x world. Make sure to convert it back to the original world. So x will be 2, which is 4. X will be 2 to the negative 2, which is 1 over 4. And the time now is... Okay, now we're at the 6. And obviously, you can either change it to log base 3 or log base x. And all the while we have been changing it to log base 3. Let's say for this time we change it to log base x and see what happens. Okay, and it will be log base x of x over. Actually, it's the same thing lah. Actually, it's the same thing. And this one don't touch. So that it will be 1. And obviously you can see we will probably do a substitution again to make it a quadratic equation, which is very clear for you. So 1 over y plus 6y equals to 5. Okay, so y, it should be, you multiply both sides by y, you should be able to get a 1 minus 6y, 1 plus 6y squared equals to 5y. So 6y squared minus 5y plus 1 is 0. And then this should be y and 6y. Okay, I'm too lazy for this, so we'll use calculator. Okay, use calculator. 6 negative 5 and 1. Oh, interesting. It should be 3y, 2y minus 1. And minus 1 each. Okay, so y equals to 1 over 3, y equals to 1 over 2. So remember to go back to the x world. So log base x. I know why it's better to change it to log base 3 now, because you see x equals to, because you see we will need one more step if we change it to log base x. So x equals to 2 cubed, which is 27, and then x half equals to 3, so x equals to 3 squared, which is 9. But actually it's a set. It's a set. Okay, 27 and 9. Number 87. Oh, I forgot the. Sorry. Just add a few more minutes. Okay, I cheat for one question. Okay, anyway. 87. I admit that I took some break in between, but anyway, this should be the time. Except for 86. 87, 2 log 2x. So we learn from our lesson, it's better to change it to log base 2 for this one. 64 is 2 raised to 6 power. Okay, and then we'll let y be log 2x, so 2y plus 6 over y equals to 7. Convert to, what's that? No, not convert, multiply both sides by y so that you will get a quadratic equation. 2y squared minus 7y plus 6 is 0. Again, I will use calculator because my brain is already too tired for this. Use 7 and 6. So y minus 2, 2y minus 3 is 0. So y equals to 2 or y equals to 3 over 2. Log base 2 of x equals to 2. Log base 2 of x equals to 3 over 2. So x equals to 4. X equals to 2, 3 over 2, which is square root of x, which is 2 sub 2. Okay. Number 88. You know, I to remind you that we have another legal move. I will do this one for this question. 2 times log base 2 p minus 6 over log base 2 of 4. Then after so many questions, you should be able to know that this is equals to 2. This 2 squared, which means this is 2 times 1. So this and that can cancel. Okay, and hopefully you know that this. Sorry. I want to combine the stuff. Okay, I want to combine the log. So log base 2 of 4 plus log base 2 of p minus 6 equals to log base 2 of p. When you want to combine, inside is plus, so it is log base 2, 4p minus 4 times 6 is 24 equals to log base 2 of p. You see, we have two logarithms side by side. 7 base, compare argument. So 4p equals to 4 equals to p. So 3p equals to 28. 24 and p equals to 8. Okay. Number 89. Okay, what should we do? I think we better bring this on top first. This power rule to bring this on top first, and then we convert to log base 2. 5 times 2 is 10 to the 4th. You know what? I shouldn't do this. Sorry, I shouldn't do this. I shouldn't do this because it just makes our life more complicated later. But actually, it doesn't matter. You'll see why. Okay. Then I change to minus 5. I put outside log base 2 for this one. X squared log base 2. 4 is 2 squared plus log 2x to the 4th 3. You see why? Because this is 5 over 2. Log base 2. Bring this one on top. 5 over 2 and this one can cancel. Right? So minus means divide x to the 5th power, then times x to the 4th power. And then happily this and that can cancel. Convert it back to index form. 2 cubed is at x. So 6x equals to 1. X equals to 1 over 6. Okay. Number 90. It has been 2 hours. Almost done. 2 hours and 15 minutes should be able to finish everything. Or 2 hours and 10 minutes. Okay, let's say 3x plus 2 log 4x squared log 2x equals to 3. It's actually exactly the same pattern as just now, isn't it? So I don't know why I get so many similar questions. Log best. Okay, change to log best 2. You know where the trick is. X squared 4, which is 2 squared, which is 2 squared plus 6. Okay, and then this is 1, 7 over 2, and this one bring here. I'm so lazy to write so many steps because you know what's happening. So log best 2 of, combine everything together, over x to the 7 times, oh, this is x to the 6. You see, they are very similar, isn't it? Equals to 3, cancel. Convert back to index form. 2 cubed is add. It looks so similar, you know. 5x equals to 2. X equals to 2 over 5. And 10 more questions to do. And then the last 10 questions are actually special questions. Like, no, not special questions. It's like we have something new to let towards the end. But never mind, only a few of them. Which is we are starting to have modulus. Modulus means we are taking the absolute value. But okay, let me show you. So if we have an absolute value, I hope you know that the absolute value is equals to positive if x is positive. You put a negative in front, so that if x is negative and it's 0, if x is 0. Means it is the absolute value of any number is always positive. Okay? So this one you convert back to index form. Absolute value of x should be 3 squared. So you can split it into 2, which is x equals to 9 or x equals to negative 9. Basically the absolute value, you see, because we are not sure whether x is greater than 0 or smaller than 0. So we need to consider all possible cases, which we make into positive and negative separately. Okay? Then number 92. Okay, this is actually a revisit of question number 25. It's a revisit to 25. Just that this time we have absolute value. But don't worry, we just do it like how we did question number 25 just now. Combine. And then you have to know that another interesting property of absolute value is that if you have absolute value of A times absolute value of B, is actually equals to absolute value of A times B. Okay? So if we want to combine them together using the product rule, we can say that it is x times x plus x. Just remember the absolute value equals to 2, and then convert back to index form with x squared plus 8 equals to 3 squared, which is 9. So again, we need to split them into 2. So x squared plus x equals to 9, or x squared plus x equals to negative 9. Then we have 2 quadratic equations to solve. Actually in the middle. 92. Then the name is x. Oh, no wonder. I was afraid that I would get x squared plus. Okay, so I'm expecting the 9 and 1. Let me clear some space. And this should be positive, this should be negative. So x equals to negative 9, x equals to 1. But then do we have to reject this? No, because we are taking the absolute value, so we will rename this answer. We won't reject this one. Then what about another option? X squared plus x equals to negative 9. And then, I don't think this one have real solution, isn't it? Because if you take the b squared minus 4ac. Oh, you do have. You have. But okay, let me check. This one is 189. Okay, it is x equals to negative 4 plus minus square root of 7, which is also okay, I think. Which is also okay. Yeah, which is also okay because you are taking the absolute value. In number 93. 2.5 lah. 2.5 hours. We should be able to finish it. Ln x plus 10 minus ln x plus 4 equals to ln x. This is a revisit to number 43. Don't worry, be happy, because absolute value of a times absolute value of b is absolute value of a times b. B is a over b. Just like absolute value, just like that. For product and quotient. Okay, so ln, you have x plus 10 over x plus 4 times with x equals to, oh, is it equals, oh, sorry. So actually you are still doing the same thing, you know. You are still just comparing the same thing. X of x plus 10 equals to x squared plus 4x of x squared plus 3x and 0, x 5 and 2, x equals to negative 5, x equals to 2. But then this time you don't have to reject negative 5 because it is inside the modulus. Okay, number 94. Log 4x equals to 3. Okay, for this one, split it. So x equals to 4 cubed, which is 64. X equals to 4 and negative 3, which is 1 over 64. Easily like that. You know what, this one directly you can see this is actually you can directly see, because if you want to compare, this one should be, what's that? Should be 5, right? So that is 1 plus 3 times 1, which is 5, which is 4. But how should we, that one? Because, okay, I know what. You have to know that if x cubed is the same as, no, it's not the same as x cubed. It's not the same. So a little bit risky if you want to take it like that. So we have no choice but to say that log 5x times x cubed equals to 4, which is weird. X cubed equals to 5 to the 4th. But I think we can only have 5 as our answer. I still think we can only have 5 as our answer. Okay. And this is 95, sorry. I don't want to go back to 65, this is 95. Because it makes sense, right? It makes sense that, okay. It makes sense that this is 1. If it is 5, then log 5 is 1. 3 times log 5 is 1. So 3 times 1 is 3. 3 plus 1 is 4. Okay, so the answer is only 5. Okay, number 96. Okay, last 5 questions. Last 5 questions. Number 96. Okay, we have layering of log. But don't worry, just convert them back to index form 1 by 1. Okay. 2 raised to the first power. No problem. So x equals to 2 raised to the second power. Convert back to index form again and again. So equals to 4. That's it. 27. Okay, ln convert, which is 1. So x equals to 10 to 1, which is 10. Okay. Number 98. Okay, luckily I stuffed all the easy questions towards the end. If not, I will collapse. Okay. So x, this one you know already, should be 3 raised to first power, then 4 like that. So 4 cubed is 64. 99. 99, I need the bigger space. Again, if you're interested to do this challenge, feel free to download the question at the description link down below. Don't worry, be happy, convert them one by one. Just the writing is a little bit. 3 squared is 9. 9 minus 7 is 2. Okay, and then you convert another layer. So don't be panicked when you see this. When you see got a lot of layers. This is 16. 16 minus 13 is 3. Okay, then you convert another layer. This is 8. 8 minus 2 is 6. Easy. 100. Oh, okay, finally we have our last question. You see, I said I can finish it in 2 hours and 15 minutes. Okay. 100. Log base 16, log base 4, 7x squared plus 4, 1 minus log base 9 of 3. Okay, we have another log here, but don't worry because 9 and 3, you know that they are related by 3. So let's say we try to clear this side first. Log base 3 of 3, we change it to log base 3. 9, which is 1 minus this 1, this 2, 1 over half, 1 over 2. Okay. 16 log base squared plus 4. No, I think I wrote one more bracket. Okay. So 16 divided by 16 raised to half, which is 4. And then 4 raised to the 4th power, which I don't know. This is 7x squared plus 4 is 4 raised to the 4th power is 256. 256 minus 4 is 252, so 7x squared equals to 252. X squared equals to this one divided by 7 is 36, so x equals to plus 6 or x equals to negative 6. Don't be careless, check. Okay, safe, because even if it is negative, when you square it becomes positive. And with that, we are done with 100 log equations. But this is not the end, because we still have like 10 more seconds. So let me give you one. Give one question 101. Okay, this is your parting gift. I give you a question, you try it on your own, and just comment the answer. Comment how you do it in the comment section down below. Okay. 101. This is a gift for you. Gift for you. Given that log base 2, okay, we have layering of log base 4 of x is the same as log base 3, log base 2, log base 4 of x is the same as log base 4. Okay, this is y, sorry. This is y. 3, then log base 2 of z, and all of that equals to 0. Okay? Find x plus y plus z. And I tell you, it's very easy. It's actually very easy. Just remember what we did with the layering just now. And I tell you, the answer should be 4 cubed is 64. Shouldn't have said it. Okay, then plus 16 plus 8, which is 80. This is the answer. Okay, so comment down below how you do this question. And that's it for today. Thanks for watching. See you guys in the next video.